Thank you for the opportunity to give this presentation today. I think this is an interesting area and really a global area in terms of manufacturing that I think is critical to really the commercial sector broadly. Obviously, DoD has its own specific interests, but I'm really going to address today more from a global manufacturing perspective and where we think hybrid electronics intersects the broader segment of this technology. And really addressing how hybrid electronics expands into electronic assembly or printed circuit boards and the opportunity space for advanced electronic packaging. As the introduction said, my name is Eric Forsythe. I'm a scientist at the Army Research Laboratory, as well as the government program manager for NextFlex, one of the U.S. hybrid electronics manufacturing institutes. So today's talk is first going to introduce hybrid electronics, but really from the context of the global manufacturing for electronics and where this emerging manufacturing capability intersects traditional manufacturing, both in electronic assembly and in advanced electronic packaging. Highlight some of the areas in which this technology can intersect technology, so manufacturing, enabling some of our technology verticals, and where those opportunities are commercially, and of course there's a parallel DoD relationship there, but predominantly focused on the commercial side of the house. I want to take a step back and talk a little bit about printed circuit board technology so we can understand where hybrid electronics intersects, and then give some examples of where we're taking this manufacturing approach towards enabling really new technologies for the world, essentially, and for the department in my case. And then some of those investments that are going through NextFlex and highlight some of the manufacturing advancements that we're currently ongoing. So when we think about electronics broadly, it's a $450 billion revenue industry globally. In my mind, it divides into three main segments. First, of course, foundry level. So this is your silicon CMOS, 300 millimeter or 450 millimeter wafers that are down at 7 to 5 nanometer lithography to fabricate very complex integrated circuits. We also do a fair amount of investment in large area thin film transistors. Think of these as backplanes for displays or X-ray imagers. In many ways, a non-traditional foundry component. Those silicon CMOS technologies are then integrated into packages, whether they're FPGAs or other 3D die stacked assemblies, and then packaged into and then with some form of a ball grid array that then attaches to a printed circuit board. And that printed circuit board brings together all the necessary intelligence to make both the silicon IC and the package perform into a system. So it provides all the passives and power and sensing and whatever other functionality. And of course, integrated on top of that is the firmware that then drives these technologies. So when we intersect that flowchart with hybrid electronics, I've highlighted kind of in the middle here several key areas that we're making investments. First, we're taking these traditional 300 millimeter wafers and thinning them and dicing them, and then assembling the direct die. So we're getting away from traditional surface mount technologies and going direct die interconnects to our overall system. You could imagine that immediately applies to interfacing and the integration of advanced packages where now we have the ability to integrate these bare die into a system or something that looks like the redistribution layers in a advanced package. Finally, hybrid electronics brings a sense of digitization to the circuit process flow. And that lets us both customize the flow for mixed volume applications or low volume applications where you're not bound to the necessary lithography steps, which you need to monetize over large volumes to really drive down kind of your manufacturing costs. But lets us customize at the